Hello, my name is Ethan McGee, and I'm with the Strategic Software Engineering Research Group at Clemson University. Today I'll be talking about an extension that we've made for the Agree verification language, allowing it to support the compositional verification of software product lines. First, a bit of background. The Architecture Analysis and Design Language, or AADL, is an architectural modeling language specifically designed for representing embedded systems, like cyberphysical systems. The open source AADL tool environment, or SADI, is a workbench created on top of Eclipse for building AADL models. The Assumed Guarantee Reasoning Environment, or AGREE, is a verification tool created for AADL and SADI that allows for the verification of components written in AADL. I'll now begin a live demonstration giving an overview of the OSADI interface, as well as giving an overview of some of the features of both OSADI and AGREE. I'll then give a demonstration of the inheritance features that we've added to the AGREE verification language. The leftmost pane of the OSADI interface represents all of the projects that are currently loaded into OSADI. These projects can be collapsed, as well as expanded to view the files that are members of each project. The center pane represents the AADL entry window. The rightmost pane is the outline view of the currently loaded AADL file. The bottom pane is the OSADI console, as well as the consoles for each of the plugins loaded into OSADI. Right-clicking an entry in the outline view gives you a series of activities that can be invoked on that component. We will mainly concern ourselves with the Agree submenu. AADL components are specified using two distinct blocks. The first is the component interface. The component interface defines the features or inputs and outputs of the system. And, when using Agree, the component interface specifies the assumptions and guarantees concerning the inputs and outputs of the system. Assumptions and guarantees are analogous to the precondition-postcondition concepts found in many other verification tools. They work by taking a behavior specification, and, assuming that the preconditions are met, the tool will attempt to mathematically validate that the guarantees hold. Agree in particular uses a satisfiability modulo theorem prover known as YISES 1. It is possible to use a newer version of YISES by changing the SMT prover setting in the Agree preferences menu. The second block is the component implementation block. Component implementation blocks contain the subcomponents as well as connections between subcomponents. When using Agree, component implementation blocks are used to specify the behavior of the implementation. We will now invoke a verification activity on the implementation to show that the assumptions and guarantees are valid for the given behavior definition. The results of executing Agree are loaded into the console window below. Green checkmarks symbolize that the assumptions and guarantees are valid for the given behavior definition. The system here defined is a simple cruise control interface that receives three inputs: whether or not the system is enabled, the target speed, and the actual speed. The system produces one event, an increased speed event that alerts the vehicle to apply the gas. One of the features of AADL used during the design of software product lines is the ability to build a component by extending another component. This allows the child component to receive the features, subcomponents, and connections of the parent. Unfortunately, native Agree does not support such inheritance, so the assumptions and guarantees of the parent, as well as the parent's behavior specification, must be copied to the appropriate place in the child. As the number of levels of inheritance grows, the component containing the Agree annexes will remain quite simple since most of the specification is inherited. However, the Agree annexes will become quite complex since each parent's Agree annex must be copied into the child. I will now switch to a version of OSADI containing our modified version of Agree that supports inheritance. We now return to our top-level controller interface specification. Note that the specification is very similar to the previous specification with one important difference. The behavior specification has changed and now includes an abstract variable. An abstract variable in Agree is very similar to the abstract variables found in Java and C++, in that the definition of the abstract variable is left up to the children to decide. However, the abstract variable can be used in calculations as well as assignments. Also note that because this component's definition no longer is complete, we cannot verify it, and we will receive an error should we attempt to do so. Let's move on to a child. We can see that the child has been greatly simplified since the assumptions and guarantees of the parent are now implicitly inherited rather than having to be explicitly stated. We can also see that the behavior specification has been simplified because it now only needs to override the abstract behavior inherited from the parent. After invoking the verification activity on the child, we can see that the parent's guarantee was included with the child because the child only has 2 guarantees, but 3 guarantees were proven. Let's move on to our more complex example. We can see that the more complex example has been greatly simplified thanks to the inheritance, especially the behavior specification. We can also see an example of where it is sometimes necessary for children to override the guarantees of their parents. In order for this to happen, you just simply need to give the new guarantee or assumption the same descriptor string as the old guarantee or assumption. We can once again validate that the assumptions and guarantees are being properly inherited because 8 guarantees are proven, yet only 3 guarantees are given. One final note is that the inheritance features can be disabled should you wish to return to the previous behavior of the agree annex. This can be done by simply adding a do not inherit statement to your annex. The tools that we've developed can be installed from the site seen on your screen. Thank you very much for watching, and go Tigers!